be a lot more than just 6. But for now, we're just going to do 6. And we're going to count how many things that we see in this loop. And the pattern is simple. You set a variable, Zork, to 0 at the beginning. We often call this variable count in mnemonic. And now we're going to run this loop 6 times. 1, 2, 3, 4, 5, 6. And each time through, we're just going to add 1 to Zork. So Zork starts at 0. Then it goes 1, 2, 3, 4, 5, 6. And we're going to print it out. So, we see the 9 and Zork is 1. See 41, Zork is 2. And Zork is 16 when we see the 15. 4 stops. And we print out afterwards. And this then is 6 is then the ultimate count that we got. So that's very, very simple. The pattern is that set it to 0 at the beginning, add 1 to it, and if you run that enough times, then this is how many times that happened. And in a sense, it's how many times this line ran, right? Sometimes you put this in an if statement, etc., etc., etc. Okay? Oops. Now, we can do the same thing to get a total. And the way the total works is you compute a running total of the number of the items that you've seen so far, and at the end the running total in effect becomes the total. A better variable name for this would be like sum or total or something, but Zork, I'll use Zork again. So you set Zork to 0, and it starts out the total we've seen so far is indeed 0. And then we're going to run this 1, 2, 3, 4, 5, 6 times, and thing is going to be the iteration variable. It's going to take on the successive values. And each time through, we're just going to take our running total and add to it the thing we've seen. So we see 9 and the running total is 9. We see 41 and the running total becomes 50. We see 12, the running total becomes 62. We get a 3, it becomes 65. We get 74, running total is 139. How many more are we going to see? We don't know. Could be a million, could be 1. Oh, it's only 1. We get a 15, our running total is 154. And what's true at any moment here is the running total is right of what we've seen so far. Now, when we're done, the for loop quits for us, and afterwards, 154 is indeed the total. So the running total while we're in the loop, at the end of the loop, after the end of the loop, we have the actual total. So it's not very difficult to convert this to the average, because we've calculated the count and we've calculated the running total, and now we're going to have the average by simply dividing those. Okay, so now this time I've used mnemonic variables. Don't get confused by this. Mnemonic variables are just friendly names I chose for you to read the code easier. I am not communicating to Python in any way by naming this count and sum, but count and sum is nice. Okay, so I set count to 0 and sum to 0. Oh, go back up. I set count to 0 and sum to 0 at the beginning, and the count is 0 and the sum is 0. And then I'm going to run this loop 6 times. 1, 2, 3, 4, 5, 6. And each time, value is the iteration variable. I count, every time I run the loop, I count equals count plus 1, sum equals sum plus value. So I have a running count and a running total. And they show up here, 1, 2, 3, 4, 5, 6, and then the running total. And then at some point, the for loop, we do the last one, and the for loop jumps out, and it divides 6, 154 is the count and running total, and then it divides the average sum over count. Okay? So that's just, again, a pattern of something in the beginning, something in the middle, something in the end. Another kind of thing we tend to do in loops is we look for things, we hunt for things. And so this is where we have an if statement inside of a loop, and of course I've created a silly simple thing. In this code I am looking for large values that are greater than 20. And again, don't think of this as just 6 numbers, but I'm looking for all the values and I'm going to print them out. So, it says before, it's going to run this 9. Well, if 9 is greater than 20, it's false, so it goes back up. 41, true, so it prints out 41, then goes back up. 12, false, goes back up. 3, false, goes back up. 74, true, so it runs this, so out comes that little print statement. Goes back up, and then 15 is the last one, and that's false. It goes back up, and the 4 says we're done, and then we do afterwards. And so this is just the notion of having an if statement inside of a for loop, where we're sort of picking or choosing or selecting or looking for something in a large set of things that we're looping through. We can also say, I want to know if a particular value is there. And so we're going to use a Boolean variable. And we've talked about integer variables like 1, 42, and then floating point variables like 98.6, and then string variables like hello world that have quotes in them. This is a fourth type, a kind of variable. It's called a Boolean variable, and it only has two values. It has true and false. Matter of fact, these if statements, they return Boolean values. Value equal 3, that is returning a true or a false based on the value of value. There's a mnemonic confusion there, right? But I'm using it. So I'm going to make a variable called found, and that's a decent name for a variable, so don't get hung up on that. And I'm going to initially say found is going to indicate to me whether or not I found a 3 in my list. And I'm going to start before the loop starts, say false, because we haven't found anything yet. So found equals false. And so at the beginning of the loop, found is false. Before the loop starts, found is false. And now we're going to run this loop a bunch of times. 9, is that true? No, skip. 41, is that true? Skip. 12, skip. Right, so 9, 41, 12. And found has remained false because we haven't done anything to it. But now in comes a 3. And this becomes true, so it runs this code. So found becomes true, and then we print it, and you'll notice that when we see a 3, we get true. And then it runs again, we get 74, it's still false, 15, it's still false, run, quit. And the residual afterwards is true. And in fact, if you didn't know any of this, and you don't print that out, all you know is that afterwards, we loop through all those things, and we know that there was a 3 in there. That's what we're doing. So we searched all of them, we checked for 3s when we found a 3, and you can see basically that, the found remains false until it flips to true, but then there's nothing to set it back to false. There's nothing in this loop that's going to set it back to false. So once it sort of catches the 3, then it remains true for the rest of the loop, and then it just finds its way out. Now, if you want to think about it for a moment, ask yourself, how might we make this loop more efficient by putting a statement right in here? Think about a way to, once you've found it and it's true, there is sort of no reason to keep on going. So what would you put there to perhaps make this loop to look for 3s, just to tell you whether or not there was at least one 3 in there, how to make that more efficient? Just think about that. Okay, so now let's look back at the largest value that we started out with, right? And so if you think about this, let's kind of give it a sort of a rough look here. Largest so far is our kind of like a running total, but it's our hypothesis is the best large number. And we have this if statement that says if the number we just see right now is greater than the largest so far, then capture it, right? Take whatever number we saw and capture it. So when we see 9, it's better, we capture it. We see a 41, it's better, we capture it. We don't capture this, we capture the 74, and we don't capture the 15, and that's how we do it. So you could think of this as better. When the number we're looking at is greater than our working hypothesis of the largest, we grab it because it's better. So this line right here is the grab line. Grab it, okay? So then the question is, how would you modify this code to teach it to find the smallest value in this list of numbers? Think of it as you have a starting number, you have a sort of what's better in this grabbing notion. How could you do that? Take a look. Okay, so let's take a look. So let's do a couple things. Like if you look at this if statement, that's better. Well, it's better now if the number is less than. So but then we should probably change this to be smallest so far, 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 right? Matter of fact, that's what this is. We've changed the word largest so far to smallest so far, and we've changed the greater than to a less than. Is that going to fix it? I'll give you a second to look at it. Pause if you need. Is that going to fix it? Is that going to find our smallest number? The answer is, of course, no, it's not. So if we run this code, So we set the smallest so far to -1, and it starts out -1. We run it, and it's 9. Is 9 less than